What's going on, everybody? This is Mr. Diamond, and this is the structure to name example problems for organic chemistry. So go ahead and I want you to take a look at these pictures. I would draw them yourself in a piece of scratch paper in your notebook or somewhere, and then try to come up with the names for all three of these structures. You can pause the video. I'm going to take a drink. My lovely Diet Dr. Pepper Cherry. And give you a moment to figure it out. So I'm assuming by this point you've either paused the video or not paused the video. So we're going to go ahead and keep talking. But if when you named these, you named this one 1, 2, 3, 4, 5, 6 hexane or hexanol because there was oxygens and hydrogens involved. Or if you named this one 1, 2, 3 methyl ethyl propane, go back and redo it because you did it incorrectly. Remember that you don't necessarily just number from left to right. That is not always the correct way to do it. You got to use those IUPAC rules. So, with that out of the way, hopefully not too many of you had to pause and unpause multiple times at this point. We're going to work through these examples one at a time. So I'm going to redraw this first one down here. So we've got HO, go up, come down, down, over, down, up, down, up, 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 down, OH, and then line down right there. Okay, so we got our first shape. Now, when we're naming, I like to list out all of the stuff that I've got. And I'm going to, just like last video, I'm going to use a whole bunch of other colors for this. So first thing I want to know is I want to know the parent chain. The parent chain is the longest string of uninterrupted carbons throughout the entire structure. So if you go from here to here, that's 1, 2, 3, 4, 5, 6. There are 6 carbons there. But that is not the way that we want to count from because there is other carbons up here, and down here. So instead, the longest uninterrupted carbon chain is actually going to be this chain right here. These guys right there, that is the longest uninterrupted chain. This is also a good thing for me to have you do on a test, by the way. Is give you a big molecule and ask you to just identify the parent chain. So on this one, we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons. So, and there is all single bonds. So that is going to be octane. So our parent chain, our parent group is octane. Now, which direction do we number from? Well, everything that's not a part of our parent chain right now, we need to figure out how we're going to name those. But to get the numbering order for them, we have to figure out which one has the number at the lowest possible point. So, for example, if we number this end as number 1, there is an alcohol group attached to position number 1. So that seems like that's probably going to be it. But if you look on this side, there's also an alcohol group on number 1. So that does not tell us. We can't just go to the first group. We're going to have to use one of our tiebreakers for this one. On the very first one I give you. Man, I am such a jerk making the first one so hard. So what we're going to have to do is go to the second point. So this one, that's carbon 1, 2, 3. If we number from this end, carbon 3 would be the first place that we run into something that's not alcohol. That's not the first group we found. And on this one, it would be 1, 2, 3, 4. The fourth carbon is where we'd run into a different group. So we're going to number from this side. So I've got 1, 2, 3, 4, 5, 6, 7, and 8. And now that I've got those numbered, we can actually go through and start describing the stuff that's attached to it. So first, these guys are similar. Now, I am normally not going to identify them by colors, but it's just a little bit easier to do that. So these guys are the same. These guys are the same. And then this guy is a lonely friend that's the only one that looks like that. So first of all, we've got the blue ones. The blue one, there are 2 alcohols. So alcohols, we change the ending to OL, but since there is 2 of them, we're going to have to change it to di, di, so it's actually going to be diol. So diol means that there are two alcohols. We don't normally have to number the position for the first one, but because there's two of them, it might be convenient for us in this case to have them on both numbered. So it's on number 1 and 8. Positions 1 and 8 is where alcohols are at. Okay, next we've got our green guys. So these are just one carbon, single carbon chains. So there are 2 methyls. 2 tells us it's going to have di. And so they are on numbers 3 and 4. And then finally our orange guy. Our orange guy is a 1,2 carbon chain. So that is an ethyl group. So 1 ethyl. And that's at carbon number 5. So we can go ahead and start working on our name. What I recommend you do is, like, let's say I give you if I give you a big space, you can just do it in the middle of a space. But if I give you a line, for example, if I do like this, I would start writing in the middle. Don't start at the beginning. So we're going to start with, I'm going to actually just switch to my black pen first. So we're going to start with our parent chain, and I'm going to put that kind of in the middle in section of my line. So we've got octan, but we have to change the ending from ane because it's going to be an alcohol. So it's octan, but we also need to indicate where those alcohols are. So it's going to be octan 1,8 diol. Octan 1,8 diol. So that's accounting for, it's an 8 carbon chain with only single bonds, and on position 1 and 8 there is an alcohol. And then for the other two, we need to list them in alphabetical order. So E for ethyl comes before M for methyl. So we're going to start over here with a 5 ethyl dash 3 4 dimethyl. Now, normally there wouldn't be this dash there, so you may also just want to rewrite it. You could number them as you go through. So another way you could do this is you could go, this thing will be number 1, this thing will be number 2, because you do all substituents in order, whatever order they should go into. And then you do parent chain, second to last, and then functional group other than these things last. So it's going to be in that order. So in that case, you would go, it is 5 ethyl, and this will end up with the same thing, but I'm gonna write it a second time. 3 4 dimethyl. And you don't have to have a dash like I said here, so dimethyl octan 1,8 diol. So all of the information is given in the name. It is an 8 carbon chain made of only single bonds, so oct-an. On positions 1 and 8, there is an alcohol, so di, there is 2 alcohols. They are on positions 1 and 8. There are 2 methyls on position 3 and 4, and there is 1 ethyl on position 5. All of the information is pent up in this lovely, beautiful, very long name. Okay, our next example, that was definitely the hardest one we're going to do, so don't freak out if you're already like, oh god, this seems really difficult. That was the most difficult one we're going to do. Our next one is a lot smaller. We're going to do this bad boy right here. So step 1, identify the parent chain. This one's pretty easy. So our parent chain is going to be this right here. Technically, you could have gone at this split, since there's a carbon on either side of it. You could have gone up or you could have gone down, and you would have still been technically correct. And you'll actually see that numerically, though, it's going to end up being the same thing. If you, at the end of a chain, have a split where it's just kind of one carbon on the second position of a on the second carbon, there is 2 branches you can take. They more or less are going to be equal to the same thing. There's nothing you really have to do. So if I number from this side, this would be 1, 2, and I would have something on position 2. And if I number from this side, it would be 1, 2. There'd be something on position 2. You'll notice this molecule is completely symmetrical. So actually, no matter what side I number it from, I'm going to end up in the same thing. So I don't have to worry about making sure my numbering is like super correct. Like there's no one way to do it. So I'm going to take this as 1, 2, 3, 4, 5. 5 carbons. No double or triple. That would be pentane. And then I've got 3 completely identical groups hanging off here. I've got this guy, and this guy. All 3 of them are 3 methyl groups. Remember, methyl just means single carbon. So for 3, I'm going to use tri as my prefix. And they're on positions number 2, 3, and 4. Because again, you have to be specific. You can't just say there's 3 methyls. You have to say exactly where they are located. So in this one, it's small enough that it's actually pretty easy for me to just list all of them off. So on positions 2, 3, and 4, we have 3 total methyls. 2, 3, 4 trimethyl pentane. And that's it. There's nothing else extra weird on this one. We've got that it is a pent, so it is 5, and there are carbons with no double, triple bonds. So that's pent and ane. And then at 2, 3, and 4, there are 3 total methyls. 3 because they're on 3 positions, and it is a methyl that we're talking about. So 2, 3, 4 trimethyl. Okay, last example. I'm going to sketch it, and then I'll have to scooch my page to make sure that I've got a little space for it. So we're going to do this, and then this, and then this, and then we're going to do a double bond or oxygen right there. See if I can scoot that back even further. Yeah, there we go. And we're going to pull this out a little. There we go. Okay, first step, identify the parent chain. Just because this is the one that's on the flat axis does not necessarily mean it's the parent chain. This is only 2, 3 carbons. We can actually number it from here. And we would get 1, 2, 3, 4, 5 carbons. So there's 5 carbons, all single. So that is going to be pentane again. And then we've got 2 things we're going to be worried about. We've got this double bond to an oxygen, and then we've got this single group right here. If we number from this side, we've got 1, 2, 3. The first thing shows up on carbon number 3. If we number from this side, we've got 1, 2. The first thing shows up on carbon number 2. So we want to go from that side. 1, 2, 3, 4, and 5. Our blue is a methyl on carbon number 3. So we don't need to do anything weird about that one. And then our green, it's either a ketone or an aldehyde, but ketones are what you name them in the middle since it's not attached to a hydrogen. So this is a ketone number 2. So this means our ending changes. Our ending becomes ONE. So now we can list all of our information again. This functional group modifies the ending, so these guys are going to go together. This is a non-functional group thing, so this is going to go first. Then we'll list this out. Then we'll put this in there. So that's the order we're going to put all of our information together. So I've got a 3-methyl pentan, because I need to cut off that E is what I cut off. Pentan, and then I'm going to do at position number 2, there is a ketone. You could also do 3-methyl 2 pentanone. Either, oh, dang it, look at me getting it cut off on the page. Either one of these names is correct. Pentan is telling you it's a 5-carbon chain with all single bonds between them. One is telling you that there is a functional group, specifically a ketone, on position number 2, and that also on position number 3 there is a methyl group. There's an additional single carbon poking off at position number 3. So there is our structure to name examples. Hopefully those make sense. I know that this chapter, and actually this whole class in general, can just seem kind of overwhelming. There's like a whole bunch of little tiny things you got to keep track of, but plenty of practice will help you feel a lot more comfortable with dealing with them. Hope that makes sense. This is Mr. Diamond signing off. Hope you have a great rest of your day.